Hello, hello. What is up, YouTube? So, I think everything is running as it's supposed to. Um, uh, so, um, let's see. Um, so I have been contemplating a bit on how to structure the code, or rather our data structures for now. So, during the last episode, whoops, I got started on the object editor here, and uh, I kind of like regretted, or not regretted. I kind of like struggle with afterwards how to structure the code itself, um, and yeah, I was trying to figure out how to lay out the data structure and the pipeline, and yeah, I thought that I might as well try to get an overview of let's see. Okay, so this doesn't work as a template, I guess. Heading now. Uh, Flowchart. Maybe not a list. Maybe a list. Can I add to the list? Huh. Huh. Let me just see. Hmm. Whoops. Is there a quick way to kind of like I have to log in. Free online visual paradigm, blah blah blah. Let's see, component diagram, I guess. Can I change it? I don't know what I'm doing here. Data flow pro. Huh. How does this work? Oh my god, I'm getting frustrated. This is pretty silly. I'm just gonna use Word, I guess. Or rather, Paint. Good old trusted Paint. So, let's see, let's have some stuff here. Okay, so, so we want to draw some meshes. On an abstract level, this should contain a transform, X, Y, Z, rotation, scale. Okay. Then we will need some mesh information. For us to create the vertices and indices. And then potentially render specific information like shader type, like pipeline. Hello, buddy. It ended up working or what? Ah, okay. Nice. What are you up to today? That's weird. But yeah, well. You know what they say. It's Linux problems. Yeah, I'm gonna work on the project and the rendering pipeline here. What are you working on? Maybe we don't want to store actually any render specific information, but this should get kind of like translated into some draw call, which could contain the actual pipeline. We need that at least. To make a draw call, we need the pipeline state. We need bindables. We need the I'm not. What are you exactly working on? Is it a database system or web page or? Oh, great! I used to work in MySQL and PHP back in the day. Did a few web shops when I was about 15, 16 years old. Actually sold some web shops back in the day. It's good stuff. So in general, we would like something like a system where we are able to submit drawable meshes of sorts, create them on the fly, and yeah, then map them into draw calls for this specific frame, since we're gonna use a sort of like scene graph eventually. Not necessarily a scene graph, but some calling. We should probably be able to submit draw calls themselves dynamically. Um, I guess that could be a structure. I'm just gonna try it out. Yeah, PHP is really easy. It's very forgiving, but it's hard to do in a safe way. Um, so basically, right now, I'm pretty sure I'm allowed to do this. Also, I don't think we should create so-called game objects for now, since they are really just a level of indirection. Yeah, okay. So I immediately regretted doing this game object stuff. So let's just comment it out. And instead we want something like a storage of meshes. Excuse me. Let's do a XM float 4x4 here. And let's do the align one matrix. And right now we won't do optimized data layouts because we don't know how to optimize. Therefore, we won't spend a lot of time on it. Right now we won't add scaling, but eventually we will. I should hold rotation and scaling later on. Then we need some mesh information. And usually we need yeah, well, I'm just doing this for good fun, so um, I'm really busy at work these days, so yeah, and I don't expect that to be any less busy for the next several months. So yeah, I won't be doing any videos. I'll just do these hangout streams where I do some uh, newbie coding and yeah, hang out with you guys. But yeah, of course, if someone suggests something interesting to do on stream. Oh, thank you, but yeah, I mean, the YouTube channel had to be pretty big to even be able to compete with my current job. So yeah, yeah, I'm just gonna hang out and uh, eventually, if I end up buying the whole real-time rendering book, I might try to implement some of the stuff from that in DirectX12 live here on stream. So that could be fun to do. It wouldn't be a video per se, but more like a Hangout live stream. Yeah, true. But yeah, being a YouTuber is not my current goal right now. I just want to hang out with you guys, hear about your projects, and yeah, work on some stuff. I'm not even close to the viewing hours that is needed for monetization anyway, so I think I need about before December this year, I need like 2,000 viewing hours. So yeah, I'm not even close, even though I'm uh, close to the subscriber goal of 500 for the minimum requirement. I'm not even close to the viewing hours. So yeah, I'm not gonna use a lot of effort to make videos and uploads since yeah, it's not really a priority for me to grow a YouTube channel. It's more like a priority for me to actually just hang out and do some programming and potentially some game development. I'm really excited about actually trying to nah, no worries, man. Let's just hang out and yeah, do some coding. I don't need no YouTube fame here. So a mesh should like consist of, well, yeah, so a mesh needs something about the vertices, indices, but also, I guess, like what kind of buffer we're using, maybe a buffer index or buffer ID, because um, potentially we could end up, yeah, having a community would be nice, but the community is nice, though, in terms of just having a community where people help each other and hang out and inspire each other. That would be nice, but yeah. And if there were any low-key monetization of the YouTube channel, if that could run a forum or a web page or stuff like that, that would be great. Just um, to allow people to talk together and discuss different stuff. But yeah, I'm definitely not in a situation where I have any sort of time to assign to it. It would end up distracting a lot from the actual programming. So yeah, no, I can actually start earning money if I have 500 subs. I can start allowing for memberships and different flair during live streams and so forth. That is actually monetization, but you need 3,000 viewing hours within a total year, and we're not even at 1,000 this year. So, and I had a lot of viewing hours in December last year, so. Um, The last couple of thousand viewing hours needs to be before December. Otherwise, we will just have to play catch up. So, but yeah, I really don't. I don't really don't think too much about it because yeah, it doesn't matter too much to me. Okay, so image could also have a unique ID, universally unique ID. Um, so in combination, whenever we like right now in our renderer here, I think we load the model that's currently in the pipeline. Yeah, temporary hard-coded model loading. So my idea was something like we could preload some meshes, but then we would like some kind of like self-expanding data structure, preload assets, meshes, create a buffer, perhaps with extra space, round it up, and then create a system around a self-expanding buffer for vertices and indices. Because right now we don't have any dynamic streaming of meshes. We don't have the need for that in this simple application. I suspect a scene right now will be preloaded. Um, I would like to play around with data streaming in the future, but it's such an advanced. Sure thing, buddy. Good luck with your projects. Nice to see you and hang out. Okay, so whenever we do this kind of preloading asset, we have render a backend call where we need to create slash expand buffers, and thank you very much, man. Much appreciated. And update their information, contents rather. Upload to the GPU. Okay. Okay, so let's start out by moving this code here. So temporary hard-coded resources. Let's see. Do we need to create? Maybe we can actually do it temporarily, meaning that let's see. Is it systems? Systems. What? No, resources. Is it file handling? Data. Object reader. Model reader. Loader. Okay. let's see if we have a crash, or if it's just fine when the let's comment this out for now. Okay. And our draw call. Let's see, our draw call. Yeah, okay, it's kind of like empty. Okay. We might need this in the future, so therefore I'm gonna copy it. So let's create a vector of mesh. Let's do meshes. Okay. We could store the file name of sorts. Maybe we want to store the file name itself for now. I'm not really sure we should do it, but maybe we should just maybe just like this. Just for now. Yeah, so how do we want to couple it? Okay, we could do an inline function of sorts. I mean, it's a sort of like a level in this in direction. I mean, if we wanted to support different APIs, we would have to kind of like abstract it away. I mean, like, I don't really want to abstract it, even though it would follow the overall architecture a bit better. Yeah, I don't want to do it right now. Maybe eventually I would do something like an abstraction, but anyway. Um, uh, we could do something like a struct. Nah. Our resources here allow us to ask the buffer for its size, right? Yeah, the size is although probably in bytes, I guess. Let's see. The size number of bytes. Yeah, so but we can always extrapolate whatever. Yeah, okay. Okay. We can just lose that structure. Okay. General methods. Um, let's see, public subsystems. Yeah, this should be removed eventually, since this data is not needed to be stored. Okay. So we want something like a void create update, but something like this. Create update vertex and index buffers. And we of course need to pass in some okay, so we need the actual data, but we also need offsets into both buffers where one mesh starts and one ends. Maybe not on this level here, because we probably don't care about the actual data, since we're not even compiling the actual draw calls here. We're just executing them inside the renderer. The renderer should probably not know a whole lot about the actual meshes. It should just receive draw calls, I think. So okay, let's see if mpoly mpoly index buffer size Oh, whoops, get size. Then we have a empty buffers means creation, else resize. Logic about resizing if needed, otherwise just update. Okay, so I guess this could be something like a simply just the data types that we actually have right here. We will have we will have several of those. Then normals, UVs, and then indices. And let's copy that. Okay, so we of course create the buffers. Huh? Are we not in agreement here? Are we not in agreement? Let's try and compile it. Error. Okay, it doesn't know about him. So I should have included the, but maybe I need a vector. Does this help? Yeah, fixed it. Ah, okay, of course. We need the namespace in the header file. And we already used the namespace there. Whoops. And the last one, of course, isn't that namespace. Okay. There we go. It should be fine now. There we go. Okay. So we could do a lazy check if, for instance, the index buffer just wasn't big enough. Yeah, we could calculate that. Anyway, let's do just the actual calculation. If the times vertices times 2 plus size of xm float 2 times vertices Actually, just let's, even though it doesn't matter, get size and poly index buffer get size. Indices. Okay. If we have space in our buffer, we simply upload it. Let's see, gxe print not implemented update upload function. Maybe not. Maybe we shouldn't update actually, because do we want to append or do we want to? Maybe we just want to create. Um, and then we want a separate update slash append function. That's more like it. Error, try to create on non-empty buffers. And on the outside, we need the information about where to offset. Okay, let's do a renderer. Is that a singleton pattern? No, not yet. Okay. Let's see. Okay. So this should allow us to call something like this, right? Oh, I forgot. Okay. I'm pretty sure that works, right? Okay. Now we can couple our guess the abstraction layer is useful after all. We could of course just make this a singleton, but I'd rather not this be a singleton. Maybe we want dual outputs, so maybe we want the rendering abstraction layer to handle whether we would render to different viewports or have separate renderers or whatever we might want. So the thinking that the backend is decoupled is pretty good. Okay, so now we can actually do the call. Whoops. Okay. Using DirectX as a namespace, of course. Okay. Okay. And then we want to migrate some of the code. Actually, we want this. Okay. How does that work? Okay. Let's step through it and see what our problem is. Probably that we have temporary information. No, not sure though. 24. Okay. So we have a problem here. Okay. Let's try to figure out what it is. Vertices 24. Oh, this gets called yeah, this shouldn't happen on construction, of course. Static void initialize. This is of course a call to that instead. And our application here. Initialization. Where does our platform layer start? Oh, it's right there. Okay. This should be better. Oh, still not great. Device was null. Huh? This is the device 0? Now that is pretty weird, I think. Because, I mean, the other initialization stuff, didn't I move it? I did move it. The other initialization stuff should be okay. Let's see. Okay. Is it due to different instances? Because this one has a device set. Okay, let's try that. We're checking that out. Okay. Step into this. Okay. Yeah, so this is actually a different. Ah, wait a minute. It's because. Ah, yeah. Okay. Yeah, it's different instances because the application actually owns a renderer. So that is. We could do something like a renderer here where maybe on construction. No, not default. Let's see. Let's see. Yeah, the problem is the instances. Let's see how to solve this in an elegant way. We could also just make the application itself static and get the renderer from that. This is what we're gonna do anyway. Maybe we should just want to pass in the renderer. Instead of making the renderer static. We could do it. Maybe that's a better way to do it. We just want the backend anyway, and we could do something like an inline. It's not really elegant, but the overall structure might change. So we could also pass along a shared pointer. Yeah. Otherwise, we should just leave the renderer as static and not store it on the application. But we would like for it to own it, so okay. Let's do something like a pass along a pointer, even though it's not great. P renderer. Oh, we need to make it DirectX12 renderer reference get D12 backend, DX12 backend. Yeah, okay. Instead of the singleton pattern, we'll do like this. Is it not public? It is. Maybe it's because of the const. Yeah. Okay. Okay, I don't have the common helpers here. There we go. Error. No error. Found. Bring resource manager initialization. Okay, so We still initialize. And now we pass along our data here. Whoops. We can remove that because we already did it. Let's see. Do we crash now? Hopefully not. But we do not compile. Resource manager. Okay, it's because we need to step out of the directory. Okay. Now, the question is, did we actually create the buffers or not? I would think that we did. I think we did. Let's just test it. We need to build in release mode. And let's try looking at our resources. The polygon. Do we? Yeah, okay, we're not creating them correctly, I think. Let's see if we are having trouble. Huh? This doesn't even get called. Okay, maybe. Oh, wait a minute. Of course, I have to pass along the renderer. There we go. And let's just step through it. Okay, let's not step through it because it's taking forever. Okay. Now we should see some polygon index buffer, polygon vertex buffer. Let's see, view contents, flow 3, flow 3, flow 2. And we're good. We're good. We're good. Great. Okay, so that migration worked. Now our resource manager creates this kind of like object whenever it gets initialized. Eventually it should of course load from file, but the next thing we want to do is to kind of like couple our mesh system here with our actual draw calls. Yeah, so we need to compile some kind of like internal list of um, what do you call it? This needs to happen at the end, uh, but we want to kind of like know how to offset into our index and vertex buffer. Therefore, uh, Let's get the vertices. These will mirror the normals and UVs, so usually we don't need anything more than that. And then we want the number of vertices. And let's just do an unsigned int vertex offset unsigned int index offset we want a number of vertex count, which is going to be actually this, and this is going to be 0, and the unsigned index count here, it's going to be actually this, our offset will start at 0. Okay, so whenever we create a mesh, which we will do here on the stack, we want a, do we want, there could be a lot of vertices. And then we want, of course, let's just duplicate this, since we want the vertex count, index count. Let's see, maybe in the future, buffer index IDs rather. Okay, so we can create a mesh. Let's close this. A mesh, temp mesh. Name equals okay. There we go. We create a name. Uh, maybe we actually want this to be the first thing that we do, just since it makes more sense in that order, at least to me. Vertex count, index count, index count, and then the temp mesh here. Index count. Okay. And then meshes. Oh wait, this is static. Okay, we push back the mesh. And then we can load the next mesh. Okay. And then we can couple our meshes here. File. And let's do something like vertex count. Index offset. Okay. Oh, wait a minute. Of course, need the unsigned integer here. Test box. Okay. All right, I'm gonna do a short bathroom break. Okay, just gotta be right back. Okay, I'm back. Let's see. There we go. Let's just adjust this. There we go. Okay. We do have a problem when we load the resources. I immediately see index offs. Oh, yeah, that's exactly it. Okay. Okay. So right now we have a mesh named test box and blah blah blah. Great stuff. Then we want something like a drawable mesh. And yeah, yeah, we want some information. Let's just start by calling it maybe we want a unique identifier here as well. Let's just start out by doing this. We basically use 64 bits for this ID. Because we could fairly easily well, I guess this is a choice between okay, I have an idea for a unique identifier, universally unique identifiers thing. Let's just do this. Maybe it will end up being a problem eventually. Okay. Let's do a drawable mesh. And let's do a UN64 mesh. A UN64 transform. Okay, but then we need a let's just do this for now. Wait a minute, we don't want that. Okay. Okay. Let's see. Okay. Okay. We want the let's see, max UN8 255. Yeah. Limited to 255 types. Hello, buddy. How you doing? Uh, uh, I don't know what do you mean. Do um, I'm pretty sure you're allowed to just join a voice channel and stream something. Otherwise, do a private call. Okay, let's see. No problem, buddy. Let's see. Return. So the first slot should be something like, of course, the buffer index, then the type, and then the version. So let me see. We'll of course test this, but mm, buffer index and let's see the logical and operator. Or let's see, bit. Bitwise or operator. Yeah. Okay. Let's do a bit shift of the type 32. Okay, let's first do then the version here. 40. Whoops. Would this be appropriate? Wait a minute. This should be alright, right? Alright, right. There we go. Okay. Maybe we don't need this because it's more like when we actually do the thing here. So temp mesh UID per buffer. I'm not sure what you mean. Ah, okay. So items. Oops, this is defined somewhere else. So let me just namespace references. Wait a minute. Okay. Resource manager. We can also do something like this. I think, right? I disagree. Oh, maybe I haven't included it. Silly me. There we go. Maybe I just actually we just want a function. Static. Mm, should we create a implementation here about we could also just do something like index type, whoops, and version. We could also do that. So whenever we need to create it, we are able to do that. Otherwise, we hello, buddy. How are you doing? Yeah, so instead of stack allocating stuff here, maybe we just want the uint64 the let's see core. Okay. 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 Let me just test this. So UID of mesh. And let's try a second version where we kind of like add these values here. And just for testing purposes, we print this to the console. Okay, for the mesh, it's strictly 0 because every field was 0. And let's grab our calculator here. Let's do a programmer's calculator. Okay, So the first 4, 8, 12, 16, 20, 24, 28, 32 bits are 0. And then we have the next 8 bits are a 0, then a 1, then 0, then a 1. Should be 10, right? Yeah. Let's just make sure. Yeah. Okay. And then the last 8 bits here. And the next 8 bits here. 30. Whoops. That's what we entered, right? Yeah, no, 20. Okay, so that is the bit pattern, which doesn't exactly correspond, does it? Oh, wait a minute. Did I not? Let's see. Huh? This looks... Oops. Now I see why. Okay, so that's 20? No. 4, 8, 12, 16, 20, 24, 28, 32 should be 0, then 0, 0, 1, 0. Okay, yeah. So the last parameter is the last part of the bits of the integer. And let's create a temporary rule here. Would we like some kind of like macro for this? Maybe we want because we will end up forgetting whatever we could do something like eval type then a 0 perhaps. Because then we could do something like this, I think. Maybe. Um, Maybe we just create an enum. Maybe that's more C++ like. Okay, let's do that instead. Maybe I need something like this, right? And let's just do a okay. Then this old function doesn't work. Okay, that's more elegant. That's more elegant because then we don't need to keep track of the types. We can simply enter them here and always make sure that we kind of like select the correct version. Okay. Great stuff. Okay, so we create the unique ID of our mesh here. Okay, so now we have a unique ID system where we can do lookups, because at allocation time I will make sure that the first part of the unique identifier here is the actual index into which the underlying buffer uh, um, got the actual mesh stored at. Then, of course, the unique identifier needs to specify a type. Right now we support 255 types of unique identifiers. Hopefully that will be enough. And then we have some version control here, meaning that I'm sorry. I'm not sure I follow. And then we have some version control, meaning that if we ever replace the specific index in a buffer or it goes stale, then whenever we replace the entry point in the buffer, we will update the version number, increment it simply, and we will know that, yeah, for debugging that it was in fact a reused buffer location. Remember, reuse is almost always better than a new allocation. So it's basically a sort of garbage collecting system, I guess you could call it. Okay, but so our drawable mesh here will simply just link up these unique identifiers, since the first part of the identifier is the first 32 bits are the index in the buffer. We can quickly downcast to a 32-bit integer and grab the index for lookup purposes. And since we will be storing everything in vectors with random access, it should be a fairly fast system. Oh, I wouldn't know, dude. I'm no expert in programming. I'm just doing a system that I want to try out in this application, but I'm no expert, so you shouldn't ask me whether something is bad practice. I wouldn't be able to judge that. I guess we will find out down the line whether this system makes any sense. Um, I only do it to avoid dangling pointers, so and reshaping of buffers. Um, that's the whole purpose of doing this unique identifier stuff. Um, no, I'm not, though, dude. I'm just trying my best. But in general, I think that globally unique identifiers and universally unique identifier systems needs to kind of like devise a way where you can make sure that no object has the same ID. And from my reasoning, I would say that if you have the buffer index, which is the data structure that holds the actual struct or class or whatever, is part of the unique identifier, as well as the type, as well as the kind of like version that got put into the buffer at that exact slot. I would have a hard time figuring out how the identifier would not differ between objects, because they might be placed in the underlying buffer at the same slot, but they would always have a different version number, at least up towards 255. But we could always expand that buffer to allow for tens of thousands. Oh, might be. You might be right on that. I might be using the wrong terminology, but for me, a unique identifier is just a number where the bit fields, the bits themselves contain information about how to identify or deduct what object you're talking about. It could be represented in hex or just straight up bits or numbers, like a hash of sorts, but yeah. I'm gonna try this approach and might have to redo it eventually. We'll see. Maybe this kind of version control here in a complex application is too limited. Yeah, probably. That's at least easier than a decimal number. Okay, so we create that. So let's also create a series of drawable meshes here. Drawable meshes, hard-coded. And the syntax would be something like, we could actually just simplify this. The instant, oops. Something like, yeah, right here we would know that. Okay, it doesn't allow me to do that. Maybe. Whoops. Let's try doing something like 4, 4 here, 5, 6, blah, blah, blah. Just so I don't leave the scope. Yeah. So that works just fine. They're created in place. Okay. This basically just creates a draw call. Drawable meshes. Let's just do this for now. And then copy this inside drawable meshes here. And then We could leave this out of scope just to not continuously reallocate that, even though it doesn't matter much, but okay. Mesh you. Okay, you want it in hex, I guess. We should do that then. Let's just int as hex. Oh, I need the extension, don't I? Yeah, I actually need this. Let's see, what is the syntax? Let's see. Let's see. Let's do this instead then. Okay. Let's just wait a minute. Okay. Where did I introduce a bug? Stack size. So the problem is not. Do I want this to be inside here or what? Yeah, that was the problem, I guess. Okay. But let's try testing this with something else. It doesn't work. Maybe. It's probably due to the. Oh, wait a minute. There we go. Never mind. Yeah. So we got a 64-bit hex now. Okay. And we can test this by let's see, ImGUI, same line, and then do a ImGUI text. Let's do file name. And let's do instance meshes dot. Let's start with 0 just for now. Name. And instead of this, we will do drawable mesh, but downcast it to a uint 32t label. Okay. this should display the file name after the file name test box. Great stuff. So as you can see, the indexing into the underlying buffer works by downcasting the unique identifier to a 32-bit integer. Okay. 32-bit integer limit. Okay, so we can at maximum create 4 billion objects in our buffer. I don't know if you will ever reach that limit. Also because we have garbage collection and reusability, so yeah, probably not. But do keep in mind that this method ends up limiting you to 4 billion instances of whatever struct you have in your buffer. Okay. Let's do something like this. Probably looks a bit more neat. Okay. So next we want to kind of like submit our draw calls here. We could create a self-expanding buffer inside the renderer here. Which would just be a vector for now. Let's do something like a uint 64 transform or rather we should probably create something like a constant buffer, maybe a buffer index, and then simply this should be a uint 64 because we could end up with billions and billions of vertices. Index count. Of course, vertex offset. uint 64. Index offset. And then we could do maybe a pipeline. No, that should happen before, right? Register doing the draw calls. Maybe other bindables. I mean, the constant buffer can contain shader-specific information, so it's only the whole pipeline state that needs to be set up for us to do the draw call. And right now we're not gonna bother with bindables. So okay. Uh, uh, Eventually we will support several pipelines, but for now we will do like this. Uh, let's just do repair frame. Nah. Create frame. Maybe just call it render because we have render then draw. I don't know. Do we want to? No, we would like the renderer to handle the logic of whatever information we will pass along here. I guess it should deduce whatever draw call we should register, right? It's gonna store it in the temporary buffer here and flush the buffer every frame after command registration. Okay. Yeah, I think this should take a type from the resource manager, data streaming. All this is simply render a backend related. So let's see, resources. Oh no, resources, resource manager. Maybe we don't want to include the resource manager all the time. Maybe we want resource types. Yeah. I think resources. Because now I can include these types here without having to include the resource manager. I think that's more elegant. Okay. Drawable meshes. Okay. Well, I would of course need to reference the buffers as well. Because, okay, maybe I need some kind of like draw call primitive. maybe I don't want, no. Uh, let's see, because we're able to send in meshes, which is the part of the maybe we just want the thing here to receive a pre-sorted kind of like list of combined. Yeah, I think that's more combined mesh information and transform information, because you would simply use a algorithm to shape whatever vectors that would be created temporarily, then you would submit them to the renderer. So let's do a mesh here, and potentially down the line we would want transforms as well. Yeah, I think that's way better, and that would be a faster workflow. Throwing pointers all around inside this step here would be pointless. No pun intended. No pun intended, and it was a bad pun. But um, yeah, it would give us a lot of indirection when we basically want to transfer data really, really fast. Let me just think. We would be copying some data here, which I don't like, but we would be copying some data here. Yeah. Basically, wouldn't we be doing the same thing over and over? Maybe we just want to. How do I end up not doing the same work over and over? Because that wouldn't make any sense. Basically, we have the data already in storage. The only thing that we would want is kind of like some sort of data selection. Uh, Maybe we want to build the draw call outside of this function, but wouldn't we end up copying no matter what? But I don't want to copy twice, do I? I mean, so the application has this information which needs to be kind of like converted into a draw call, since this is part of a draw call and this is a part of a draw call. Maybe this is not needed. And maybe this is not needed, but anyway, I'm confusing myself. So a draw call is basically a registration of this stuff. Right now we're not gonna bother with the pipeline stuff, meaning that we can disregard this part. We're not also not setting any oh, this is also part of the pipeline. So right now we're only interested in this draw call right here. Meaning that for every frame we would like polygon draw calls. We want to call this after we're done doing whatever for loop here. Which would be kind of like some version of this call here. And of course added with a transform binding before. So I would like to transfer the actual draw calls maybe I should just do whatever I decided to do. So this won't look like a pretty signature, but it will at least work. And we will still allow the renderer to kind of like do whatever logic it wants to do. And okay, maybe I figured out how to not do the copying more than once, because the drawable meshes here will be the kind of like pre-sorted list that we use to do our lookups. Then we have our buffers here, which we will just pass references to. Maybe we could signify that this is actually a variable and this is some kind of storage. This is probably some stack allocated temporary in another scope that we create. Let's see, transform matrix. We'll just do it for now. Okay. I think this is better. Okay, so this will be pre-sorted. Then for each call, we will have a mesh, which we will downcast to get the index, which means that we have a Okay. Let's do a mesh index transform index. We won't be using it, but okay. Then we will do a Directx12 draw call. Draw call. Let's see. Right now we actually don't need this, but we will keep it for later. Let's do this. Needs to be assigned due to internal buffers with reference to the of the transforms. Yeah. Okay. The draw call here. Let's see. What did I actually? We actually only need the index count, right? If I remember correctly, yeah, we will do the number of index counts, instance counts. It doesn't matter. Start index locations, the base vertex location as well. So we actually don't need the vertex count itself. We will store the information in terms of if we ever want to edit something outside of this part of the code. Okay. And now we should be able to, what's the polygon draw calls? There we go. Okay. Let's see, and the not last two components, but there we go. And we should be back at rendering our Oh, we're not. Okay. Let's see. Okay. Oh, of course we're not calling the render function. That's why nothing gets transferred actually. Okay, so this is our kind of like reshaping. So that also means that if we did frustum calling or something, whatever we decide it goes into this vector here will get drawn to the screen. That means that calling can happen outside the renderer and it only has to register a draw call. Okay. Yeah. So in our application here, we would like something like maybe, yeah, I mean, I have an abstraction layer, but uh, okay. I mean, I can always do like this, get DX12 backend. It's not pretty, and I don't know how the coupling should be made, but for now we will use this. Okay, and then we need the resource manager to be able to uh, access functions. Get drawables. This will of course not be the way that things are handled eventually, but for now we will do like this. Static inline. Get meshes. Get mesh buffer. Okay. Also, I immediately realized that this should not be used right now because we're gonna define this as a null pointer. Right. Resource manager. Core, of course. Get drawables. Get mesh buffer. And then a null pointer. Okay. And we're back to having a box. So basically, we should be able to create more meshes. So let's create a new mesh in Blender and load it. Um, mm, mm, let's see. Uh, Let's do some weird shape. Yeah, that's fine. Specimen. Is it with a T? I actually think so. Okay, forward minus C. That seems correct. Write materials now. Triangulate faces. Write normals. Apply modifiers. I don't know. I think that's it. Okay. No, I would definitely not want to save that. Okay. So since we're hard coding everything here, we should then update our vertex offset with our vertex count and our index offset. Oh, whoops. With our index count, and then we can. What did I actually call it? Refresh specimen. Whoops. Yeah, Visual Studio for some reason has a object viewer. Okay. And then we update the minus the. Wait a minute. Yeah. And the index count should be like this, right? Next model. Clear. Let's try and look at our output. Okay. We have 70 vertices, 108 indices, and we need to offset like this. Okay. So I want to just look at the locals here. Locals. Oh, I can't access the actual instance then. Okay. Okay, it disappears. Anyway, we knew that it, what do you call it? Got loaded. Anyway, so when we do our drawable here, let's just try swapping swapping this, and we got our new object here. And the lookup is correct. Okay. The problem is right now that we don't have any way of controlling our object placement because we have no transforms. So even though I could create several objects, well, maybe they would kind of like just intersect with each other and look all weird. Let's try doing this then. Okay, yeah, they will. Now we have a combination of our two objects. So that means that our pipeline actually works as intended. So we now have a dynamic renderer. The next thing I would like to do is to implement, of course, some functionality to actually add and remove objects, edit objects. That's more GUI oriented, and probably just a lot of boilerplate stuff. But we also would like some matrix implementation. Yeah, so what we need to do here is actually create some transform stuff, create a basic directional light in the shaders for our viewing pleasure, and create some GUI stuff for editing. Sorry, I got distracted. Okay, so that's the general outline here. Yeah, but I need to grab myself something to eat since I'm pretty hungry. And yeah, that's just what I gotta do. But so far, this has been pretty great. Yeah, I really like the system of doing drawables that simply just link some IDs, and the transformation from draw calls into that is pretty easy. Yeah. We could probably couple the whole drawable mesh with a bounding volume of sorts for frustum calling. Yeah, that would be fairly easy to couple. So yeah. Let's see. Did you implement it? Maybe post a screenshot in the Discord server. Anyway, I'll be it's understandable. Right now, I just don't feel like GUI programming. I would rather work on a render and maybe some gameplay stuff. So yeah. That's great to hear, man. Anyway, I'll be going for a dinner break, so I'll be back later. Keep on trucking, buddies. Thanks to everyone who dropped by during this stream here. Hopefully I'll catch you later. If not, I'll probably stream a bit during the weekend. Although I'll be busy until... Yeah, see you too, buddy. Good luck with your project. Looking forward to seeing some screenshot of it someday. All right, everyone, please take care. Bye-bye.